Hello, the purpose of this video is to show a full adder circuit in Logic World. The purpose of a full adder is to have a half adder circuit and a second half adder circuit, hence a full adder. And the reason for two half adders is you need to add your inputs and you need to add a carry bit from potentially a preceding operation. So we will construct one. I've already constructed one to demonstrate it. And I've used a horizontal and a vertical board here for compactness. And here's my switches for input. So if we take 0 plus 1, that's our input pin there. This is our output. The answer is 1. If I take 1 plus 0, the answer is again 1. And if I take 1 plus 1, the answer is 0 with a carry. That output pin is the carry. And then if I add in a carry bit, the answer is 1 with a carry. So I will just duplicate the construction of this just to kind of walk through the principles a little. When building circuit boards, you can hit T to change the orientation here. All right, so now I have my circuit boards in place. I will build my first half adder. And a half adder is a AND gate for the carry operation, and an XOR gate to sum the inputs. If you're having trouble rotating things, make sure you hit G to grab it. Sometimes you can just rotate it by hovering over it. All right, so I have my AND gate, which basically produces the carry output, and the XOR gate, which produces the sum. So each input goes to both of the two gates. And we could test this. It's kind of easy to test as you go. Make sure I didn't do anything wrong, but 0 plus 1 is 1. 1 plus 0 is 1. Add them both, and I get a carry with an answer of 0. So that's what we want. So then we have to build our second half adder. We'll use these through pins to go through the other side. And we'll ignore the carry input for a minute. Oh, actually we won't, because that won't work. All right, so I will add my carry input pin here. I'll connect my input here, my switch. And that will go straight through to the second side because we're going to use the second half adder to add the carry input. So there'll be two carries, the carry output from the first adder and the original carry input. Okay, so that is the carry, that is the sum. So come over to the other side, we're actually flipping these over. I have to sort of place those and then, or rotate place and then remove them for whatever reason. Is they're a little awkward. Misclick there. All right, so our inputs are the original carry input from this switch that comes through this through peg. And the second input is the sum output from the first half adder. And this pin here is the carry output from the second half adder. We'll deal with that in a minute. We'll just test what we have here. So 0 plus 1. Okay, why isn't that working? How did it was working perfectly, and then what did I do here? Did I drag a wire I shouldn't have dragged somewhere? Let me just double check my wires here. There seems to be a wire that's not supposed to be there. I don't know how that happened. A wire accidentally, I made a bad wiring connection there. Okay, so I have the result of 1. So 1 plus 0 is also 1. 1 plus 1 is going to be 1, 0. So there should be a carry bit. And that's because I have not put that in yet. So I'm going to put my output pins. This is the sum output. This is the carry output. And the carry output will be the OR of the carry output from the second half adder and the carry output from the first half adder. And if I just try to drag that directly, it's blocked. So then I'm having to use this mount here. There's a way to resize the mount, and I can't remember how. Okay, I'm not going to try to figure it out in this video, but you should be able to resize that mount like I did here. Is there a resize button? I'll just check real quick here. Resize component is just V. Let me just try that real quick, see if I can do that. Yep, okay. So I'm just resizing that to make it a little less protrudy. I think I can make that the minimal size there. Then place the peg. That's just a little more compact, doesn't stick out as much. All right, so the answer when I add 1 and 1 is 0 with a 1 carry. And then finally, if I add 1 plus 1 plus 1, I should get the output of, I didn't drag that there, 1 with the carry of 1. So that works. That's a duplicate of this board here. Now we have 2 boards, we can make a 2-bit adder. So what I would do is I would take the output of this and input into this, but I only need to output the carry. So I'm just taking the output of the carry here to input to the carry here. And I wouldn't use this switch. And I wouldn't use this switch. So our carry input for the low bit is 0. It's always 0. And the carry input for the high bit is from the first full adder. All right, so we should be able to test this. We'll take 0, 1 plus 0, 1 and see what our answer is. 0, 1 plus 0, 1 should be 1, 0. So that's not working. I'm just thinking why, because it's pretty straightforward. Oh, I'm doing that wrong. Am I doing that wrong? These should be the high bits, so these should be 0. And these should be the low bits, so this should be, yeah, I always screw that up in my head. So 0, 1 plus 0, 1 should be give me 1, 0. And I look at the carry output from the final carry output. So there's no carry, which is correct. And the answer is 1, 0, reading these two pins. I'm not going to do all of the options here, but let's take 1, 0 plus 1, 1. So 1, 0 plus 1, 1. And I'm just going to do that on paper. 1, 0 plus 1, 1. Our low bit should be 1. Our high bit should be 0 with a final output carry. So our answer then, the low bit is 1 as expected. The high bit is 0 as expected with the carry. So that works. So there you go. There's your 2-bit adder. It's a little more interesting to do like a 4-bit adder, I think. All right, thanks for watching.